Hello, my name is Tammy Miller. In this episode of Galvanic Cells, we're going to learn to identify the anode and cathode of a galvanic cell. To identify the anode and cathode of a galvanic cell, we first need to understand what a galvanic cell is. A galvanic cell is an electrochemical cell which generates energy through a spontaneous set of redox reactions. What this means is it will give off energy. An electrochemical cell is a cell that is composed of two different half cells. Each of these half cells will contain a solid metal electrode, and then there will be an electrolyte solution that electrode is immersed in. When we look at our redox reactions, there is always one electrode where reduction will occur and one electrode where oxidation will occur. Reduction always occurs at the cathode, and oxidation always occurs at the electrode that we call the anode. We can summarize this by the mnemonic anox, red cat. This means that the anode is always oxidation, and reduction always happens at the cathode. Anox and red cat. To identify which electrode is the cathode, there are a couple of things that we need to do. First thing is we will be given a set of reduction potentials. Usually this comes in the form of a chart. And I know it's a reduction potential because it'll have the form E0 RED, short for reduction, or it'll just say reduction potential. When we look at the charts of reduction potentials, the most positive of the reduction potentials will always be the cathode. The most positive reduction potential means it is the most likely to be reduced. And then the electrode with the lower or least positive reduction potential is going to be the anode. So if we look at what we have in the picture below, what we see is the anode is happening on the left. This means that this has the lower reduction potential. And on the right, we have the cathode. And the cathode is where reduction will happen. This means that I have the higher or the more positive reduction potential. They're not always drawn with the anode on the left and the cathode on the right. Let's look at a question that gives us a chart to help us understand how we can use reduction potentials to determine the anode versus the cathode. So use the table of standard reduction potentials to answer the following question. And they want us to label the anode and the cathode in the following galvanic or spontaneous cell. When I look down at the bottom, I see that I have two different things. I have solid silver in my left half cell, and I have solid magnesium in the right side of my half cell. So I have to use the chart above and find silver and magnesium. Silver is right here and has a reduction potential of positive 0.7994. Magnesium is over on the right and has a reduction potential of negative 2.37. It's obvious when I look at these two that my silver has the more positive of the two reduction potentials. This means that silver is more likely to be reduced. Since we have red cat and reduction always happens at the cathode, I'm going to label the left side where silver is as the cathode where reduction will occur. This means that the magnesium must be the other half cell, which means it must be the anode, and the anode is where oxidation occurs. Let's try a second one. We have the same table of standard reduction potentials. And again, they would like us to label the anode and the cathode in the following galvanic cells. In the left side, I have lead, and on the right side, I have aluminum. So I look up at my chart, and lead is right here, and it has a standard reduction potential of negative 0.126. Aluminum is on the other side and has a reduction potential of negative 1.66. Even though they're both negative, we can figure out which one the cathode is. I mentioned earlier that the cathode will have the most positive of the reduction potentials. Since lead is the closest to zero, it is a more positive reduction potential than the aluminum's reduction potential of negative 1.66. This means that the lead is more likely to be reduced, meaning that the lead will be my cathode where my reduction occurs. This makes the aluminum my anode where oxidation occurs because it is less likely to be reduced. Being able to identify the cathode and the anode in any electrochemical cell that is given to us is very important for being able to understand if we have a galvanic cell and what that cell potential is, which we will discuss in another section.